Hello and welcome to helpyourmath.com. In this video, we are going to look at question 19 from the Math 206.5 Final Exam Review. In question 19, we're given the graph of a function. We're asked to identify various things about the function, the domain and range, then evaluate at specific points, the intervals on which the graph is increasing, decreasing, or constant, and then the x and y intercepts. So we're going to do each one of these on separate slides. First, we're going to start with the domain and range. What is the domain? That are all the x values that are represented by this graph or equation. We're given the graph, so we focus on the graph. And because we see these arrows, that does indicate that the graph is continuing in that direction at that same shape. So it's going to just be this line that's going up to the left, which indicates to me that we have no least point. There's no smallest x value, right? Because if we were to keep drawing this line, it would keep going up, 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 and keep going left, 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 left. So we're starting at negative infinity. And then there is a break in the graph, but it still remains that it's defined at each point. So we have to have this open circle here because if we had two closed circles, then it wouldn't be a function, and this is supposed to be a function. So even though there are breaks in the graph, there's no break in the domain. It still is going to be defined at -4. It's going to be defined down here at 1, and then it goes to the right, getting bigger and bigger and bigger. So the domain will be from negative infinity to infinity. The range are all the y values that are represented by the graph or the equation. So y, we're looking to go up or down. If I know that this one, based on this arrow, is going up, and I know this one's going up, if we look to see how far down the graph goes, it looks like right here we have a minimum. So this graph does have a minimum, which means the range will not be all real numbers. The range will start at -5, and -5 is included because there is an open circle there. And then it has no largest value, so it would be from -5 to infinity. So that would be the domain and range. Question B asks us to evaluate g of -3 and g of 1. For this, we have to look to the graph. So g of -3, this is an x value of -3. Here's -3, and here's where the graph is defined at -3. It looks like g of -3 has an output of 1. So we say g of -3 is equal to 1. We base this off where we see the graph at x equals -3. How about x equals 1? So 1, we're looking for where, this is an open circle, that's not where it is. It's down here at -5. We would say that g of 1 is equal to -5. When x is 1, y is -5. Here we're looking to see on the intervals in which the graph is increasing, decreasing, or constant. Where is the graph going up from left to right? If I kind of scan along the graph, let's see, it's going down here. It's not going up or down here, it's going up here. So that's the interval on which the graph is increasing. That interval starts at 1. When we do these intervals, we use the x values. So it starts at 1, and 1 is included because there is that closed circle. And then it's going to increase as long as x is getting bigger and bigger, which is going to take us to infinity. So the interval in which it's increasing is x equals 1 to infinity. Next, where is this graph decreasing? So a graph is decreasing in any interval where the y values get smaller as we go from left to right. And that would be all the way to the left here. Even though there's that arrow going up toward the negative direction, if we go from left to right, if I'm going to draw that from left to right, I'd actually be moving my stylus down, which is exactly what I'm doing. So that indicates that that's the portion of the graph where it's decreasing. So it starts decreasing, there's no start, so we say negative infinity, and then it will promptly stop decreasing at 4, -4, that is. There is an open circle there, so it is not decreasing at -4. To indicate that, we do use a parenthesis. So the interval in which this graph is decreasing is negative infinity to -4. And please note that graphs could have multiple intervals in which they're decreasing. This one happens to not, but it is possible that there's more than one interval on which a graph is decreasing. Lastly, where is the graph constant? This one's pretty rare. Since this is a piecewise function, it's a little bit less rare, but generally we only see increasing and decreasing, except for in this case where we do have a little interval that is constant. So it's constant when it's neither going up nor down. It's just keeping even keel, which it's doing in the middle from -4 over to 1. -4 is included, but +1 is not, because there's that open circle there. And keep in mind when we're doing these intervals, we're looking at the x values. We focus on the x values. Those tell us the intervals. It's the y values that are telling us what it's doing. Is it increasing, decreasing, or constant? But it's the x values that we plug in to say, this is the interval of x values on which the graph is increasing, decreasing, or constant. And last but not least, what are the x and y intercepts of this graph? For this, again, we have to look at the graph and see x-intercepts are where the graph crosses the x-axis, or we can say it's where g of x is equal to 0. So that would be here. Here's a point that's on the x-axis. That would be -6, 0. Any x-intercept will have that y-coordinate of 0. And looking at the x-axis, here's another x-intercept at 2. So we have two x-intercepts, -6 and 2. The y-intercepts are where the graph crosses the y-axis, or we would evaluate, if we were given the equation, g of 0. So plugging in 0 anywhere we see an x. A function can have at most one y-intercept. And that y-intercept, so where are we crossing the y-axis? Right here at +1. So the y-intercept is at 0, 1. This has been question 19, kind of looking at different pieces of a graph. Thank you for stopping by.